Hi grade 11s, great to be with you. We've got such a surprise for you today. We're dealing with this human circulatory system and watch out.
Look what I've got.
Now, we're not going to tell you exactly what we're going to do, but all I can say to you is hold on to your lunch. That's a clue.
We hope they've had their lunch.
We hope they've had their lunch.
We hope you keep your lunch down, okay? But it's a wonderful learning experience, and it's something that many of you never do in your classes. So that's what we're trying to do here. We're trying to give you, listen, we're spicing up. We learn extra. We're spicing up the whole education system. There we go.
Okay, so guys, how do you get hold of us? Make sure that you get onto Facebook, and that address www.facebook.learn/learnextra. And
you want to start that again, John?
Sorry, I'm rushing. www.facebook.com/learnextra. Like our page, get on, chat to us. Sorry, Indy's not here. Maybe it's because she wants to keep her lunch.
You know what? I mean, look at John. He's so cute. I mean, guys, come on. It's so nice to have a boy here because normally we're sort of female-dominated here, you know. Okay,
so enough of that chit-chat. Let's get on and do some real learning about the circulatory system. And we're going to take a short break, and then we'll be back straight after this.
Cool.
Welcome back, Mindsetters, Life Sciences, grade 11, and we're into something that is so amazing and so brilliant, the circulatory system. We don't want to miss a beat on this one, so make sure that you stay tuned and that you get all your questions onto the Facebook page. Coming up is an amazing thing that we're going to be looking at. So I'm going to hand straight over to Kathy because I don't want to waste too much time chatting, but get onto the page as well. I'm chatting. Unfortunately, Indy's not here today, but still the same process, same show. Get hold of us. We'd love to hear from you. We'll hand over straight to Kathy right now.
Hi, boys and girls. Welcome. We're going to do circulation now. People, please understand, circulation is a whole section of work. It's not just the heart, it's not just the lungs, which, by the way, is part of the respiratory system, but also we breathe so that we can get the oxygen into the blood and the carbon dioxide out of the blood. All right, so, and all of that, the process of getting this stuff around our body is by the heart, or because of the heart that pumps all the blood. Now, you must learn there's a table between the open and a closed blood system. Use your common sense. An open blood system means that the blood flows in a cavity. So in a hemosyl, for example, like an earthworm, it's got this little big cavity area, and the circulation occurs through there, and there's a heart, and it pumps things around. Okay, a heart is just a pump. Nothing but a big, fat pump. The problem is when that pump stops working, you're in big trouble. So please learn a table that shows open blood system and a closed blood system. We have a closed blood system. Insects, for example, your arthropods, will have an open blood system where it's just in this cavity and it mushes around. Okay, so closed blood system means it flows in blood vessels. All right, now, lesson number 1. Any vessel that exits the heart and is on its way away from the heart, and that's the rule. If it's on its way away from the heart, it's an artery. If it's on its way back to the heart, it's a vein. All right, and venae cavae means main vein. All right, superior, above. Inferior is from below. So the inferior venae cava will bring blood from below the heart, and the superior venae cava brings blood from above the heart. These are all terms you should already know from having done them from grade, heavens alive, grade, I think it's 4 that you start natural sciences and animals and blah, blah, blah. Okay, superior is above, inferior is below, all right? Any artery carries blood away from the heart. Any vein carries blood to the heart. And it doesn't matter if it's oxygenated or deoxygenated. If it's moving away, it's an artery. Think A for away, A for artery. And if it's moving into the heart or it's on its way back to the heart, it's a vein. All right, so basic human circulatory system. Now, if we look at the circulatory system, and let's just take this back. I want space. Circulatory system is actually divided into two systems. Okay? You get the pulmonary circulation. Okay? And you get, now look at the word, systemic circulation. Okay, now if we look at the two, what is the difference? Because these two make up circulation in our bodies. Pulmonary has to do with the lungs. All right? So pulmonary circulation means the blood flows through the lungs. Systemic circulation comes from the word system. Okay, so think about this. Remember, in grade 8 and 9 and 10, we do organelles of the cell. The organelles make up cells. Cells make up tissues. Tissues make up organs. Organs, whole variety of them, make up a system. And lots of systems together make us the organism. For circulation to happen, in other words, to get the blood around the body, what do we need? We need two systems to work together. One is the pulmonary system, and the other is the systemic circulation. Pulmonary circulation, systemic circulation. Systemic takes it to all the parts of the body. Pulmonary, well, we got to put oxygen in, take the carbon dioxide out, and swap the blood around so that it can go back to the heart to do its job. So, what does the heart do? It pumps the blood around the body. Why? Why do we need this blood, this stuff, this red stuff flowing around our bodies and feeding vampires and all that kind of thing? Why? Why do we need to do this? Because in order for a cell to function, and you did this last year, in order for a cell to function, it has to have energy. Where does it get the energy from? Well, the cell makes the energy. How? In the mitochondria. Okay. And what does the mitochondria need? Or what does the cell need to make energy? Well, firstly, it needs oxygen. And secondly, it needs glucose. So it will oxidize the glucose to produce what? Carbon dioxide, water vapor or water gas, water, okay, and ATP, adenosine triphosphate, which is our energy carrier. Now, we've got everyone going down to the Argus this weekend, and they're going to be riding in the Cape Argus cycling race. Yeah, okay, so they're going to be doing that. Those guys are going to need an incredible amount of energy. Where? In their muscle cells. So are their hearts going to be pumping? Oh, yes, they are. All right, and they're going to be pedaling away. And I hear Seikabossi is apparently a piece of hill that goes up at this rate. So how are they going to do this? Their heart is going to pump. And it's going to pump 10 for a dozen. Why? Because it's going to be circulating oxygen from the lungs, okay, and nutrients, which is in the blood, which has been absorbed by the digestive system, to those muscle cells so that they can produce energy so this person can do well in their cycle race. What are they going to exhale? What are they going to excrete? Okay, carbon dioxide. So it doesn't help getting all this oxygen in. The lungs have to get the carbon dioxide out, but from where? From the blood. Why? Because the blood has come from the cells back up to the heart and back to the lungs. So, if we look at the two circulatory systems, okay, they work together. Very simplified diagram, and if you look at this diagram and you remember it, you will never, ever, ever mess up a double circulation. All right, which is what we have here. Circulation, pulmonary and systemic. And this is very simplified, but just close your eyes when I'm finished. Look at this picture, close your eyes, and I promise you'll never get it wrong. Here we go. You all can see that's a heart. I mean, we've just had Valentine's Day, heart. And I can't do it in red because you won't see it. Okay. Then we have, now, there are the lungs. All right? Now, I mean, you're saying, oh, for heaven's sake, Kathy, your diagrams are awful. I know, but you know what? They're going to help you to remember. So here we go. Lungs. And we have two of them. Heart. Okay? And we have all the parts of the body down here. Okay, so I'm going to just put here body. Now watch this. And it's so beautiful. I'm going to use pink because then you can see it. The blood is going to come from the heart. It goes out of the heart and it goes to all the parts of the body. Okay? And it goes around and everywhere that it's supposed to go. And it goes to the kidneys, and you'll have some blood feeding the heart muscle itself. And it's going to go to the digestive system. Okay, and it's going to go to all the legs and whatever. All right, all this blood goes everywhere where it's supposed to be. And it ends up coming zhoops into the heart. Okay, so it's gone from the heart to all the parts of the body. That's what I've done in purple. Okay, now lime green, here we come. And once it gets to the heart says, okay, so hello, I'm sitting here with blood that's got nutrients, I've got blood that's got a whole bunch of carbon dioxide, and carbon dioxide isn't good. So what do I need to do? It says, okay, well, you know what? We'll take this blood and we are going to take it and send it to the lungs. Why? So the lungs can take the CO2 out and put oxygen in. Okay? The blood goes into the heart, and from here it goes zhoops to all the parts of the body again. Now, what I've done in green is pulmonary circulation. What I've done in the pink is systemic circulation. So, to make it very easy, the blood goes from the heart, out the aorta, zhoops, to all the parts of the body, to the brain, to the arms, to the fingers, to the legs, to the kidneys, everything. The cells get the blood. Well, when the blood finally gets to the cells, because you've got arteries, arterioles, capillaries, which we're going to do in detail next week, venules, they all come together again, and the veins. And now they start coming all the way uphill back to the heart. And it says, how's it, Mr. Heart? We've got nutrients because you come from the digestive system, but guess what? We've also got a lot of carbon dioxide. This is deoxygenated blood. So what do? It says, okay, not a problem, hun. Let's pump it to the lungs, because the lungs' job, pulmonary circulation, is to say, out with the carbon dioxide, in with the oxygen. Out with the carbon dioxide, in with the oxygen. The blood is all refreshed, still has nutrients, still has waste, because the kidney's job is to take the waste out. Okay, and it goes zhoops into the heart, and then the heart says, okay, fine, we've got our oxygen, let's pump it to all the parts of the body again. Any vessel that leaves the heart is an artery. Any vessel that's on its way back to the heart is a vein. Remember that. It doesn't matter what it's carrying. Oxygen, deoxygenated. If it's an artery, it's moving away from the heart. If it's a vein, it's moving to the heart. Now, here is the human circulatory system. This is the pulmonary circuit. So what we've got, and I need to find a very nice bright blue color. Okay, when we color the diagram of the heart in, whatever's in blue shows deoxygenated blood. In other words, the body has used the oxygen. Whenever it's in red, oh, it's nice red blood, then it is oxygenated. In other words, it's full of oxygen. Okay? But, have a look at this. The right pulmonary artery, it's an artery. Now, what do we have with an artery? Okay? Arteries carry blood to the heart. Pulmonary veins will carry blood away, veins carry blood to the heart. Arteries carry blood away from the heart. Now, if we look here, what's this artery doing? It's going from the heart and it's taking this blood and it is pumping it to the lungs. Okay, is it moving away from the heart? Yes, it is. So, therefore, it's a pulmonary artery. But look at the color. The color tells you that this blood is deoxygenated. And that O2 with the X through it is a catheism. All right, you can't use it in an exam. That's my way of explaining it. But that is my symbol for deoxygenated. Has no oxygen. All right, that's leaving the heart. Therefore, it's a pulmonary artery. Okay, but now look at this. Here we have the left, the right pulmonary artery, the left. And you're going to say, now hold on, why is this side right and that side's left? It's because if you do a diagram, it's as if you're looking at someone who's lying in front of you. And if someone's lying in front of you on a table, like if you were a doctor, that would be their right side and that is their left side. So that's how we label our diagrams when we draw them. It's as if we are looking at the person lying in front of us, okay? So, pulmonary artery carrying blood away from the heart, okay? Left pulmonary artery carrying blood away from the heart. So, one will go to the right lung, one goes to the left lung. But now, hold on a minute. Look at this. We've got pulmonary veins. All right, and here we have left and right pulmonary veins. Wait a minute, there's a problem here. We say, and I'm going to have to use, I'm trying to look for a nice big bright color that you're going to see here. I'm going to go with lime green. Let's see, because I want you to make sure you can see. Now look, on this side, in the right lung, the lung has said, okay, here's the blood. Out with the carbon dioxide, in with the fresh oxygen, and back to the heart, so the heart can pump it to all the parts of the body. So, this is what happens. It goes in here, and if it's going in here, it is coming back into the heart. And remember the rule, if it enters the heart, it is a vein. But look, what's this vein carrying? The vein is carrying oxygenated blood. Belinda, can we see the green? Okay, perfect. Belinda is my producer, and woe behold if I use a color that she can't see. So as long as you can see it, that's cool. All right, so it's coming in. And look here, the left pulmonary vein bringing what kind of blood? Oxygenated blood from the lungs. Now, you've also got to remember that this right side of the heart only pumps blood to the lungs and then back to the heart again. So it's not a long distance. It's like right here. But the left side of the heart is going to pump blood to every single organ, including the lungs. All right? Because remember, the lungs are like a butcher. The butcher works with meat all day, but he still has to have his samis and his lunch and his little snacks. He can't, because he's working with meat. It doesn't just go into his body. That applies to your liver. It works with blood, but it needs its own blood supply. The kidneys, they need their own blood supply. They have to take blood from what they are using. And then you have your heart. The heart muscle also, the lungs also, they work with blood all day. They need their own blood supply. So the left side of the heart is there to pump blood to all the organs in your body. And that is why, believe it or not, when you swear to something, you know, when you swear to your country, you swear allegiance, you take your right hand and you put it over your heart, because this is where your heart is. And this is where the blood pumps out to the rest of your body. So this is why we do this. When you are, or like this, I swear to you, there. It means that you are being honest and serious. And it comes from way back when, old days, before they even knew where the heart was. They just knew it pumped sort of here in this area. Okay, it's always slightly to the left. So, pulmonary artery, okay, takes deoxygenated blood away from the heart. It's pumping away from the heart to the lungs. Pulmonary veins pump oxygenated blood from the lungs back to the heart. That's why they're veins. The aorta, which is this main big thing over here, that aorta pumps blood to all the parts of the body. Okay, and the venae caves, which are the main veins, this one here, Let's just get our blue. This one in there and this one in there, from the bottom of the body, from the top of the body, inferior, superior, are bringing the deoxygenated blood back to the heart so it can take it back to the lungs. So pulmonary circulations, heart, lungs. Heart, lungs, okay? And systemic circulation to all the parts of the body. John.
Thanks, Kathy. I hope that's got it clear. Now we're going to a short break. After that, we're going to zoom in to the heart of the matter. Don't go away. We'll see you in a few seconds.
Okay, guys and girls, what we've got here on the board, and John's putting it onto the Facebook for you, is the double circulation between the heart and the lungs and between the heart and the rest of the body, which is systemic circulation. Why? As vertebrates, we have a closed blood system. Everything is closed in blood vessels. All right? Now, here is what we are going to be doing today. And as I do this, John is going to be showing you what the different parts are. Now, if you can follow me. Alrighty, looky, what I got here. Okay, I have got gloves. Why? Because I have no intention of getting this under these nails. Alright, so you can be a teacher, you can be a learner, and you can still be a bit of a, I think it's a kugel. Alright? But anyway, here we go, gloves on, and okay, let's just get these on. They stick, but yeah. When you use gloves, by the way, people, if you're doing experiments in class, just please make sure that you're not allergic to latex, because your hands can get messed up. Alrighty, all set and ready to rock and roll. Now, our butcher is awesome. And I have to tell you, so is John, because John organized this. He even cut it in half for me, which means that he sort of thought, well, you know, Kathy's probably a bit of a doof blondie and didn't know how to do it, but okay. So we're going to imagine this nice fat heart. And you see all this fat here? We do the external structure first. The fat is there to protect the heart. All right, so Tebogo, have a look here. If you can come in nice and close. See, we've got our own cameraman here today, but if we look here, look at all this nice fat, and that is to protect. However, people, when you have all this fat around a heart, especially when people are overweight, it causes incredible pressure on the heart, incredible pressure on the blood. And remember, this heart is made of muscle, so it's got to do this. And if it's all layered in fat, it can't do that. And that's when you end up with a heart attack. Okay, so we don't want that. This little ox here, nice fat ox, that's all I can say. All right, now, first thing I'm going to show you is, Tebogo, if you can come in very, very close here. We have this nice thick membrane that is around the heart, and it's not on our diagram really, but I just wanted to show you this. It's a nice thick membrane, and this nice thick capsule is what it's called, all right, is what the fat will then attach onto. And remember, the fat is just adipose tissue. And girls, if you look here, you see how the fat layers have formed here, and they form in little clumps. That's what gives us orange peel legs and cellulite. So you've actually got to massage it, and when you massage it, it flattens out those little lumps. Just a beauty hint there while we're at it. And I can see John's looking at me and he thinks I'm nuts. But girls, you understand, don't you? All right, if we're looking at our heart like this, it's got this kind of, now I mean, I don't know where the little heart shape for when we do Valentine's comes from, but this is it. All right, and girls, by the way, talking about Valentine, if a boy ever says to you he loves you with all his heart, it's not worth it. But if he says to you he loves you with his entire hypothalamus, then it's worth it. All right, and you'll be doing the whole the brain and all that soon. So just remember, hypothalamus, he's worthy. All right, so there's the basic shape. Now the heart, if we open it up, okay, and here I'm going to need Tebogo to come in nice and close. Now our butcher has given us two wonderful, let's put this down. Okay, I think this one's got a nicer view to it. I'm just trying to find all the parts. This here, okay, clearly it's been cut sort of sideways here, but this big fat thing over here is what we end up with as the aorta. Right, so there it is. So John, if you'll show us the aorta.
Which is that.
It's that whole round arm thing as it comes out. Okay, there's your aorta. Nice big fatty. Okay, if we look here, and I just want to see if I can, and I'm not getting my finger in, oh, here we go. All right, that, if you can see my finger, let's get a Cokie here. Here, all right, can you see that? Now remember, this heart is like that. This is the right, sorry, that's the right, this is the left. All right, so if this is the right side of the heart, there, what is it telling you? It's telling you that that thing there is your superior venae cavae. It's coming here into this round space over here, and that little round space over there is your right atrium. Okay, so right atrium, John, do you want to show us? There we go, the right atrium over here. All right, this area here, all right, joins. And when it joins, it literally divides the heart into two halves. Okay, so we have two halves, a left side and a right side. In this case, the heart I'm looking at, right side, left side. All right, and we'll focus on it now. But there is a division, and that division, John will show us now, is the septum. All right, can you see it? There's the septum. And what the septum does, people, is it divides the left side from the right side. Now, why would that be important? Because on the left side, we are going to have oxygenated blood. And on the right side, we are dealing with deoxygenated blood. The left side of the heart is going to have a thicker muscle wall. Now, if you look here, Tebogo, see how nice and thick that muscle is there. And the same with this one. Look how thick the muscle is there. See, compared to the left side, where the muscle is much thinner. Now you say, hang on, why would that be? Think. Where does the right side pump the blood to? To the lungs. That's it. To the lungs. I mean, whoa, big distance. So much. But the left side of the heart, people, look here. This has to pump blood to every single cell in your body. So this is mega. It's got to be strong. It's got to be really good. And that's one of the questions they can ask you, especially your IAB learners. They love to ask you things like that and say, oh, and why is this side thicker than the other side? Well, guess what? Because, hello, the one pumps to the lungs, this side. The other side pumps to every cell in your body. It must have a nice, thick, strong muscle to do so. Okay, back to our heart. Now, we've divided or separated the heart with a septum into left and right. But now we're going to divide it even more into quarters. And we have these two little things at the top. They're sort of roundish. And we have two longer things. Now, what are they? Have a look here, Tebogo. Let me just see which ones are. Okay, here, there is the atrium, and there's the ventricle. A for atrium, because the A is higher, it's the top, and V, because it's in the V of the heart. So that's how you're going to remember it, all right? As if we look here, there's the ventricle, all right? And here's the nice big fat atrium over here. So atrium is on top, ventricle is at the bottom, all right? Now I'm going to move across there because I just want to do something on the board. And Shane, John, I'm going to see if I can get as much blood off my hands as possible, people. If you look, I'm going to try and, no, we can't. Okay, that's your atrium. And there is another atrium. That's the one for that side of the heart. Remember, right, left. Okay, and then this part here is in the V. So that's your ventricle, and that's your ventricle over there. So atrium, atrium, ventricle, ventricle. And if we had to do this, and you know those horror movies where you've got there's your heart. Okay? So what have we got? We've got the atrium, the ventricle, the ventricle. Clearly there's an opening in, come here. Clearly there's an opening here, and there's an opening there. And then this goes out that way, and this goes out that way. So, look at it. 2 eyes, a nose, and or maybe a beak. You use your imagination. But this is going to be the left side. That is the right side. Okay? This is the top. A comes before V in the alphabet. So, atria on top, ventricles at the bottom. So, we've now separated our heart out into 4 parts. We have got the septum, which divides left to right. Okay, so there we go. There's your septum, left to right. We have the atrium over here. Now, this is beautiful. All right, and the ventricle. And this nice big fat aorta, because remember, at least, hang on, we just feel here. That comes in there. All right, so nice big fat structures. Why? This blood has to go to all the parts of the body. So it's coming in, and then it goes up here. I'm trying to find my hole. Comes in here, and there we go. There's your aorta. So the blood's going to come out of here. From where? From our left ventricle. All right, so we've got our structures, people. Now, I want you to come in very, very close, please, Taboho. And I just want to see if we can see it better on... The whole idea was to show you a closed and an open. Okay, look. What have we got here now? Here's the atrium. There's the ventricle. And if you look here, we've got these little cords here. And if John will just show us the cords, but he's just getting to the diagram. All right. These cords here are called chordae tendonae. In other words, tendinous cords. They are strong cords. They are very strong cords. Why? Because they are going to allow the blood to go down here, flows into the ventricle. As it gets into the ventricle, it's now got to make sure that this area here doesn't allow blood back into the ventricle when into the atrium when the ventricles contract. So, people, atrium, ventricle, chordae tendonae, all right, which John has just, yeah, you've got those cords over there, he's shown you nicely, and they're your chordae tendonae. And what do? They stop this entire flap. If you want to just put on my hands here, Taboho, it stops that valve from the atrium to the ventricle from doing this when the ventricle contracts and pushes the blood out. So they're going to sit here like your valve sits like that. The blood flows through from the atrium to the ventricle, and then when the pressure's in the ventricle, it closes the flap. And these cords stop it from going in the opposite direction.
Can we just look at the valves again, or can you get in there?
I'm going to see if I can find a really undamaged one. Okay, in here. So it's coming here, all right? The blood's coming in from the atria, in through the valve, into the ventricle, this area here. Let's see this one here. Okay, here you can see the valve very nicely. The valve closes. So here your chordae tendineae. Let's just get this blood out of the way. Your chordae tendineae, and there's your valve. So the blood goes from the atrium through here into the ventricle. Once the blood's in the ventricle, it's going to contract. When this muscle contracts, it pushes the blood up. So the chordae tendineae stop this little valve there from flapping this way. And if it does, if there is just a little bit of blood, that when that ventricle contracts and that little valve doesn't close properly, guess what? We end up with what we call a heart murmur. And it means that you're never ever emptying your atrium properly because some of the blood keeps coming up into the ventricle. All right, so very important now. Let's just see here. John, I want you to just show the learners the mitral, the tricuspid valve and the mitral valve. So atrioventricular valves, which is what we're doing here now, people. So this here is between the atrium and the ventricle. So, whoa, very difficult. It's the atrioventricular valve. So it's the valve between the atrium and the ventricle. Now they've got special names. So the atrioventricular valve, which is on the right, is a tricuspid valve. It's got 3 sides to it. And the one on the left is called a bicuspid valve, and it looks like a half moon. All right? So it's your mitral valve. Okay, so you've got your mitral valve, okay, or bicuspid, 2 sides. And on the right, you have your tricuspid valve, okay? And those valves are important because what are they doing? They are making sure that the blood goes from the atrium into the ventricle. And when we do heartbeat and stroke of the heart, probably next week, you are going to have to remember atria work together, ventricles work together. Right side of the heart only pumps blood from the heart from the rest of the body into the heart to the pulmonary arteries, okay, and to the lungs. All right. Then the blood from the pulmonary veins, oxygenated, comes into the heart, and it's entering the heart, so it's a vein, and that then goes to atria, ventricle, and out via the huge aorta. And the aorta is massive, as John showed you earlier. It's a huge round structure. And I mean, if you look at the size here, it's big. Right, it is huge. People, now, the valves. We've got 2 lots of valves. The one lot of valves, I'm going to see if I can I wish there was a pause button here, but I know there isn't. I'm just trying to find.
Kathy, shall we go to a break?
Yeah, let's go to a break quickly, and then I can find all my holes. All right, so John?
You take it.
We'll see you in a minute. Let me just find all my holes. I'm going to stick pens on them, okay? See you now. Okay, people, welcome back. I found my holes. All right, so here we go. The problem is that our little heart here, all the vessels have been cut close to the heart. We should have actually said to the butcher, because our butcher's awesome. But I'm going to show you now. We've got 2 lots of valves, all right? As John showed you, Nana. You've got the tricuspid valve, which is on the right, between the atrium and the ventricles. And you have the mitral or bicuspid valve on the other side, okay, on the left side. And that's between the left atrium and the left ventricle. That's going to pump blood to all the parts of the body out through the aorta, and the other side is going to pump blood to the lungs. Okay, now, once the blood goes, now I want you to watch here. This is a ventricle that's been opened up. Once the blood comes here, it's in the ventricle, it's now going to bypass the ventricle here on the side. Let's just zip that. It's going to bypass the blood on the side here. Okay, there's your ventricle and your atrium's closed. This valve here has now closed. Blood's come in, valve is closed. Pressure from the ventricle, and now the blood passes through here. Okay, and this here is one of the pulmonary. Now, is it leaving the heart? Is it coming into the heart? It is leaving the heart. And if it is leaving the heart to go to the lungs, it is the pulmonary artery. Remember that. And it's carrying a whole bunch of deoxygenated blood. All right, now if you go back to our diagram, John's busy highlighting there for us. Okay, there's our pulmonary artery. Now it comes out as one structure, which will then divide into the left and the right sides. Okay. And that's taking, but in there, now remember, when the ventricle starts to relax, what happens? The blood's going to flow backwards. So, what have we got in the ventricle? And I'm going to see if I can actually carve this so we can possibly see it. Okay, if you look at this little structure over there that I've cut through, all right, that is called, or it's half of a semi-lunar valve. And the semi-lunar valve only applies, it's in this direction. So your semi-lunar valve is here. The blood's coming from the ventricle up into the semi-lunar valve, all right? And as it goes into the semi-lunar valve, there's pressure. The blood's being pushed into the pulmonary arteries. But when there's a lack of pressure and the muscles are no longer contracting, and that's important, the valve closes quietly. So we've got two sets of valves. We have four structures with a septum in between. So look here. There's our septum in between, dividing the left and the right sides of the heart. We have the atrium nicely over there, and then we have the ventricles inside here. Now remember, this has been cut open. So there's your ventricle. Atrium to the ventricles. We have a valve. These valves here, okay, are your bi- and tricuspid valves. Tricuspid on the right, bicuspid on the left. Held in place by the chordae tendineae. Okay? And the chordae tendineae makes sure that these valves here, between the atrium and the ventricles, definitely do not flip inwards. So the blood only ever passes into the ventricle. And the chordae tendineae makes sure that that's what happens. So the blood passes through our ventricles here, from the atrium, through the tri- and bicuspid valves, into the ventricles. From the ventricle, it's now going to pump, psh, and this blood's going to go chippy, 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 up this side. Okay, here it's going to go up into the pulmonary artery to go to the lungs. And that's going to split into the left side and the right side. And on this side of the heart, the blood's going to go, psh, and I can't find my hole here, but it's sort of going to go past the side here and zhoops up out through the aorta. In the aorta and in the pulmonary artery, and John will show you now, put a big X there, John. So inside the pulmonary artery and inside the aorta, we are going to have semi-lunar valves. It looks like a half moon. And those semi-lunar valves are going to stop the blood from coming back into the ventricle. So how does the blood work? Let's recap. Here's our little heart again, Tebogo. We've got 2 minutes. The blood's going to come in. It's going to go into the atria. Oh, there's an atria and an atria. Remember, this is the other half there. Atria. Into the ventricles. All right? From the ventricles, zhoops, pulmonary artery and aorta. And we've got 2 lots of valves. We have our bi- and tricuspid valves between the atria and the ventricles. And what else do we have? In the pulmonary artery and the aorta, when there's a lack of pressure in the ventricles, the blood's going to flow backwards. We then have our little semi-lunar valves that just go chip, and that's your heartbeat. When these valves here, your bi- and tricuspid valves, when they close, it goes plop. Why? Because the blood's coming up from the ventricle and it's pushing. So it goes coops and it closes. That's your lub sound. That's the doof in your heartbeat. And then when the blood goes psh, and out here and chips up into my hole, which I can't find, up here, into the pulmonary artery and the aorta, it's going to now, there's no pressure, it starts to come back and it goes, choops, it closes it so beautifully. And it's all gentle, it's a gentle closing, and that's your dub sound. And if you listen to your heartbeat, it goes doof, 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 lub, dub, lub, dub. And here you have your heart. Remember, it's very important that it works properly. Look after it. Clearly this ox didn't. All right, over to you, John. I think
well,
we're
Kathy,
going to finish off now, so.
Thank you, that was great. I hope you've all enjoyed that and that you've got lots of questions. Now remember, now next week we're going to continue with the circulatory system and we'll add the lymphatic system to that. Please post your questions, we'll try and answer them, and remember to stand by. Grade 12s if you're watching, we're back up in a few seconds, but grade 11s, thank you so much for being here, and goodbye. We'll see you again soon.